Welcome to the introductory tutorial for PhotoModeler's road scene mapping. In this tutorial, we will work through the basics of setting up and producing a drawing of a road scene in PhotoModeler. The goals of this project are to show how to photograph a simple scene, how to use PhotoModeler to generate a drawing, and how to use evidence markers. We use a simulated scene and EOS's evidence markers, but what you can learn here is easily applied to real scenes. By default, PhotoModeler is installed with its full menu and tool set. If you will just be modeling road scenes, a subset of these tools is available. If you go to Preferences, Tools and Menus, change the type to 4, Road Scenes, say OK. It warns us we must restart PhotoModeler for the new menus to be displayed. Close PhotoModeler and restart it. There is now only a subset of the tools displayed. This small number of tools are all you'll need if you'll be modeling road scenes. The menus are also much shorter, but if you do need to access a tool which is not displayed on the menu, you can expand the menu to access the full set of tools. We start by selecting Points-Based Project from the Getting Started dialog. Browse to the folder where our images are stored and add the first two images, A North End East Side and A North End West Side. Click Next. After clicking Next, we see that PhotoModeler has found a matching calibrated camera in our camera library. This was created using the calibration procedure outlined in the calibration tutorial. Press OK. If a matching calibrated camera was not found, as it has not yet been added to your library, use this pane to locate a project that contains the camera calibration. We will use the Load Camera from Disk option. Hit the Browse button and find a PhotoModeler PMR project file that contains the camera. Our project setup is now complete. While the scene does not have any vehicles, skid marks, or yaw marks, there is enough here to learn the basics of PhotoModeler. We will be solving for the positions of the evidence markers, as well as some simulated debris and some road markings. We start by double-clicking to open Photo 1. We switch to subpixel marking mode, which allows us to identify circular targets in images. We tap the plus key to zoom in on target A. We click down near the center of target A and drag the mouse to create a box around the circular target. When we release the mouse, PhotoModeler will search this portion of the image for a circular target and identify the center of the target. A correctly identified target will have a plus marking symbol drawn in the center and a red ring identifying the edge of the area PhotoModeler identified as the circular target. We use the minus key to zoom out, and then zoom in and mark target B. Zoom out. Find target C. Another way to zoom is using the scroll wheel on the mouse. This works similarly to the plus and minus keys. Click down near the center and drag to mark target C. Zoom out. For target I, we can demonstrate another zoom technique. If you press and hold down the Alt key, a magnified window around the area of the current mouse location will pop up. Click in the magnified window, drag around the area, release marks target I. We can use the Alt Zoom technique to mark target D and target N. Now that we have 6 points marked with a reasonable spread across the image, we can mark them on a second image. Double-click to open Photo 2, which shows the same targets as Photo 1, but from a different angle. You want to choose a second photo that is as far away as possible from the first photo and provides a good angle separation. We mark the same targets on Photo 2. Press and hold Alt. Mark target A. Release Alt. The same for target B. target C, target I, D, and N. If we go to Window, Photo Windows, Zoom to fit all, we can see both images side by side. The next step is to tell PhotoModeler which points match between the photos. This is called referencing. We switch to referencing mode, which brings up the referencing pane. We activate Photo 2 and select all the points on the photo. The selection causes Photo 2 to become the referencing source. The blue box around the edge indicates that this is now the source. The source is also stated on the referencing pane. We move over Photo 1, causing it to become active. The first point on Photo 2 will be highlighted in yellow. We need to identify this same point on Photo 1. When our mouse is close to a point, the cursor changes to indicate the point will be selected. We find the matching target for A and click to reference it. The highlight on Photo 2 automatically advances to the next point. We find the match for target B, followed by target C, I, D, and N. Now there is sufficient information for PhotoModeler to process the project. The position of the camera when the photos were taken has been calculated, or what we call oriented. You can tell that Photo 1 and 2 have been oriented by the camera icons on their thumbnails and by the text in their title bar. We switch to Select mode and open a 3D viewer. You can see the 3D positions of the targets we have identified are solved. If we turn on camera stations, you see the solved positions for both cameras. Turn off camera stations, and we're looking at the points again. We can now add some non-target points. These can be points of interest in the scene, or if you do not have evidence markers, crisp, clear edges can be manually identified to help orient and solve the camera positions. Switch to Line mode and mark the top of the F in the word Fire Lane over here. Click to mark the top of the F. Move to the other end. Click to mark the top of the E. Line mode can be used to create marks, as here, or it can be used to connect lines between already existing marks. We switch back to reference mode to identify these newly marked points on Photo 1. We select the point at the top of the E and move over to Photo 1. Because both photos are now oriented, we see a reference helper line. If a project is solving correctly, the matching location for this point should lie along this line. No mark exists here yet, but when in Mark While Reference mode, we can click to create a new one which will become the reference match for the point highlighted on the reference source. We click on the top of the matching point on the top of the E. Go over to Photo 2 and select the top of the F. We go back to Photo 1, see the reference helper line, and because a line is drawn between these 2 points, there is a rubber band connected to our mouse indicating a line will be drawn between the point and where we reference to. We click to mark the top of the L. Over here we can see the 3D positions for these points and the line connecting them. We can now save this project. Go to File, Save Project. Because the file doesn't have a name yet, we choose one. We'll call this 2photos.pmr. Click Save. This project is included in the tutorials if you wish to load and examine it. We can now add a third photo to strengthen our solution. Close the 3D viewer. Go up to File. Add Remove Photos and select B Middle from South End, East Side. add it to the project. We add this photo because it shows the same targets we used in photo 1 and 2, but from a different angle. This photo is looking back towards the north end where photo 1 and 2 were taken. Where possible, such as an intersection, it is a good idea to take photos that surround the scene. This ring method will help you with a wide selection of angles and views of the scene. We close photos 1 and 2, and just like we did with the first two photos, we double-click to open photo 3 and mark the targets. Switch to target marking mode. Mark targets N, D, I, C, B, and A. Now that the targets are marked, we switch to referencing mode and identify the corresponding targets on photo 1. Double-click to open photo 1. When in referencing mode, the first point you select assigns the photo as the source. If you want to switch the source, simply click the Clear Source button and select the Mark to Reference on the photo you would like to act as the source. In this case, we'd like photo 1 to be the source. We select target A. Move over to photo 3 and reference the target here. Target B, C, and I. Once we reference this fourth point, there is sufficient information to orient photo 3. We will now reference these remaining targets to strengthen the project. Now that both photo 1 and 3 are oriented, when we go to reference the point, Photo Modeler displays a reference helper line. A helper line is displayed for each photo the point is referenced on. This point is referenced on photo 1 and photo 2. If a project is solving well, the reference location should lie along these lines, close to their intersection. This point is located here. The last mark is referenced here. Because automatic processing is turned on, each time you add a reference, Photo Modeler refines the camera and point positions in a project. We open the 3D viewer and turn on camera positions. You can see how we are surrounding or encircling this part of the scene. In order to perform measurements, we need one known distance in the scene. It is a good idea to make this scale a relatively large distance, as any error in the scale measurement will be reflected throughout the project. In this case, we know the crossroad distance between target A and target B is 186.5 inches. We go to Project, Scale, and Rotate, which opens up the Scale and Rotate dialog. We select the Units and Scale tab. We set the project units to inches and enter a scale of 186.5 inches. We then select point A. Hold down Shift and select point B. Both points are now selected and highlighted in red. We press the Define button. The S tag appears with the points indicating that they are used to define the project's scale. Switching to the Rotate tab, we can add a rotation to the project. We select point A on the left, hold down Shift, press point B on the right. Now click Define to define the horizontal x-axis. Now we select point C in the front. Hold down Shift and select point D in the back, and press Define for the y-axis. The reason we use two sets of disjointed points for the axes is so we pick axes parallel to the ground in both cases. Defining this rotation tells the project which way is up, down, left, right, etc. We press OK on the Scale Rotate dialog and our units, rotation, and scale are set. We can now perform measurements on the project. We open up the Measure pane and select this line. The distance between the line and its two endpoints is 157.31 inches. If we select point A, hold down Shift and select point B. This measurement will match the scale we set, 186.5 inches. We're done with measurements, so we close the Measure pane. If we want to extend the scene further down the road, we can continue marking targets there. Switch to Target Marking mode. Mark Target E, Target F, and M. Do the same on photo 2. On photo 3, only target E is visible. We mark it. We can now reference our newly marked points. We go to Window and Tile to rearrange the windows in an easier format to use. Switch to Referencing mode. By default, points on photo 1 are already selected. This made it the source photo. We go to Clear Source and click on this mark, which will make photo 2 the source photo now. We move over to photo 1. The reference helper line indicates where this point should lie. The point is also drawn in blue as a reference helper line intersects it. Select that point, indicating it's a reference match. Photo 3 has two reference helper lines because this point is marked on photo 2 and photo 1. Hold Alt and select to make this match. This point located on photo 2 here. This point does not exist on photo 3. To complete the scene, we can add the remaining points at the south end of the road. The targets here are quite small, so we hold down Control and drag a region. When we release the left mouse button, it zooms to the area we surrounded. Do the same in photo 1. The targets here are too small to identify using Subpixel mode, so we will manually identify the centers of the targets using Mark Points mode. Hold down Alt. Carefully mark the center of target G, and the same for target L. The target behind it, the furthest point away, target J, and target H. Once they are all marked, we switch to referencing mode. As we did when referencing the letters of the top of the word fire lane, we can mark and reference points at the same time. Select a point on photo 2, move over to photo 1, and click to mark the point in the center of the target. This generates a pop-up warning that tells us the angle is low. By default, any point with an angle less than 10 degrees will not have its 3D position calculated. We can reference the remaining targets, selecting them on photo 2 and marking them in photo 1. We switch to Select mode and open up a 3D view. If we turn on Show Rays on selection of point or camera station, now when we select a point, a line is drawn between each camera and where we mark the target. These lines should intersect at an angle as close to 90 degrees as possible. This is important to consider when taking your photos and choosing which images to use. You should try to get a good spread of photos and not just walk down the road in a straight line. You can see as we get further away from the camera, the angles get worse. Further down here, the points that are referenced do not even show up in 3D because their angle is less than 10 degrees. You can review the angles of each point using the point quality table. Table, point quality. Go over to the angle column and sort by angle. You can see our lowest angles are below 10 degrees. If we select a point above 10 degrees, the 3D position is shown in the 3D viewer. We can improve these angles by adding more photos further down the road. This time we will add photos pointing in the other direction, from the south looking north, to surround the scene. We go to File, Add, Remove Photos. Add the 2 photos from the south. We will mark the photos one at a time, starting with Photo 4. We double-click to open it and use the Sub-Pixel marking tool to mark the points on the photo. When the targets start getting too small, we can use manual marking mode to identify their centers. Switch to Sub-Pixel marking. Add this one more target, which we missed here. Target N. Now that we have marked all the targets on this photo, we will reference them with Photo 1, which was taken at the opposite end of the road. Open up Photo 1. Switch to referencing mode. We click to select a point which identifies it as the source photo. We select this point on Photo 1. The blue line surrounds it, indicating it is a source. The source is indicated over here as well. Then reference these points on Photo 4. Alt-zoom in. Reference this point here. Same for this point. Select points along the photo with a reasonable spread. Marking target I, Photo 4 now has enough information to orient. Continue referencing points, which improves the solution. You can see Photo 4 is now oriented so we get reference helper lines, giving an indication of where the matching point should lie. Target M. Target F. Target E. We have now referenced all the points that are visible between these 2 photos. Now we mark Photo 5. Double-click to open, again using subpixel marking and switching to manual marking when needed. Mark J, H, K. The targets are getting a bit hard to see, so we switch to manual marking.